Today we're going to discuss how to calculate the expected values in a parallel circuit. We will be using a purely resistive circuit. We'll be using resistance values of 50, 25, 10 ohms, and we'll be using applied voltage of 48 volts. First thing that we need to do for a parallel circuit is find the total circuit resistance, and to do so there are three different methods for a parallel circuit. The first method is the resistors of equal value. And in that method, all branches of the circuit has to have the same resistance. So you take the resistance value of one branch and divide it by the number of branches. We can't use that in this one because we have different values for our branches of the resistance. The second method would be the method of the product over sum. It works real well if you have two branches, but if you have more than two, then you have to make additional calculations to get the answer. The method that we're going to use, the third method, is a reciprocal formula. It'll work on any of the parallel branches. And the reciprocal formula looks like this. We take 1 and we divide it by, open the parenthesis, 1 divided by the value of the first resistor, plus 1 divided by the value of the second resistor, or branch, plus 1 divided by the resistance of the third branch. You can either use the reciprocal key on your calculator, or you can enter it the way I have. If you enter it like this, make sure you use the parenthesis key. And once we calculate that, that comes up to be 6.25 ohms for a total circuit resistance. Now, one of the rules for a parallel circuit is your total circuit resistance must be less than the smallest branch resistance. And so we do meet that criteria because 6.25 is smaller than 10. Another rule for a parallel circuit is the voltage is going to be the same across every branch. So we can go ahead and fill out these values with the 48 volts applied voltage. The next step that we're going to take is finding the current for the circuit. The current is going to take our applied voltage, and we're going to divide it by the total circuit resistance of 6.25, and that's going to give us 7.68 amps. We also need to find the current drops of the individual branches, and to do so, we'll take the applied voltage, and then we're going to divide it by the resistance of the individual branches. So for the first branch, we'll have 0.96 amps. And then we'll do the second one, 48 volts. This time it'll be divided by 25 ohms. And that'll give us 1.92 amps for that branch. And then we'll do the third branch, the 48 volts, and dividing it by the 10 ohms, and that's going to give us 4.8 amps. Now a good check to see if you did the math right and didn't leave one out is the sum of the individual branch currents is going to equal the total circuit current. And it does in this case. So the final step we have to do is find the power for the circuit. The power is the amount of work that circuit is capable of doing. To find that for the total, we're going to take our applied voltage and we're going to multiply it by the total circuit current of 7.68, and that's going to give us 368.64 watts. We also need to find the power dissipated by the individual branches. And to do that, we'll take the applied voltage of 48 volts, and then we'll multiply it by the current drop for the individual branches. And so our first one is going to come out to be 46.08 watts. And for our second one, we'll take that same 48 volts. This time we'll multiply it by the 1.92 amps for that branch, and that's going to give us 92.16 watts. And then finally we'll do the third one here, the 48 volts times the 4.8 amp drop, and that's going to give us 230.4 watts. And again, we can check our math, make sure we didn't leave one out. The sum of the individual branch currents is going to be equal to the total, or excuse me, the individual branch wattages is going to be equal to the total wattage. Now that we've computed all the expected values of this circuit, we can use that when we go to and make our live readings on the circuit and compare them to see if we need to look further into that part of the circuit or move on to a different part. Thank you and have a good day.